so for isosceles triangles, there's some properties that we have to know that apply to all isosceles triangles. Okay, so if it's isosceles, that means that my sides are what? I have how many congruent sides?
3.
With isosceles?
2.
A triangle with at least 2 sides that are congruent. So if you look over here, that side and that side, which are considered my legs, but those are the congruent ones. Alright, your legs are the congruent sides. Your vertex angle is where the 2 angles meet. So your vertex angle will be up here. Just labeled for you. Your base is the third side of the triangle. It is opposite of the vertex. So your base is down here. Kind of makes sense because the base is normally the bottom. Your base angles are angles created by the legs and the base. So your base angles would be here and here. It's very important for you to know. Your base angles are really important. Alright, I want you guys to write this down. I'm going to type it in so I can have it. So for the base angles theorem, it is if 2 angles of a triangle are congruent, then the angles opposite them are also congruent. So if 2 angles of a triangle are congruent, then the angles opposite them are congruent. And I'll draw a picture in a second. And then for your base angles, this says if 2 angles of a triangle, and if you want to use your abbreviations you can, or your pictures, are congruent, and the sides opposite them are congruent. So you basically just wrote the same thing twice, it's just opposite. So I'll draw a picture so you can kind of see what that means. So the first one says if 2 angles of a triangle are congruent, then the angles opposite them are congruent. If I have a triangle, and let's call this triangle A, B, C. Alright, so if it's isosceles, we have 2 marks there. That means that if AB is congruent to AC, then angle B is congruent to angle C. So if they give us those hash marks where we see AB and AC, if those hash marks, which means congruency, if those 2 things are equal, then the angles B and C are going to be equal to. And the base angles converse is saying the same thing. If they mark, if we have a triangle, that's called ABC, and they mark these 2 angles, like B and C. That means if B is congruent to angle C, then we can assume that AB is congruent to AC, just opposite. So that means we're always looking for either the congruent hash marks or we're looking for the base angles to have that little arc on it. Something else to think about. If a triangle is equilateral, the triangle is equiangular. What that means is if we have a triangle, they already told us that all the sides are the same, then I know that all the angles are the same. And the flip side of that, if the triangle is equiangular, so all the angles are equal, then the triangle is also equilateral. So sometimes you'll see that we'll write both of those words down together because it is both of them. Any questions here? All right, so the best practice is to just do it. Look at this diagram. Number 1 says segment AB is congruent to what? What would AB be congruent to?
AC.
Why do you say AC?
I don't know.
There has to be something. What gave it away?
Oh, the little two little.
The little arcs, right?
Yeah.
Okay, so that's right. Chris realized that the arc that's on angle B was also on angle C. So that means that these lines, AB, is also congruent to segment AC. Let's look at angle BDE. This green angle here. BDE is also congruent to what? ECB? I guess that's, well, okay, you see how BDE only has one hash mark on it, right? So we could do, could we do BED? Yeah, we can do BED. I'll do that in blue. Because we still only have one hash mark and then our base. Does that make sense? So it is also congruent to angle BED, or you could write DEB. Same thing. All right, let's do the last one. I'm going to clear out all this space. All right, so they're saying that CBE, so CB to E, I have how many hash marks there? 2, right? So CBE is congruent to something, which is congruent to BCE. And BCE also has 2. So what could go in the middle? We're looking for, it has to be in this triangle. If I go from CBE, I have,
BEC.
BEC, good. I can go from BEC, I still have those 2 hash marks, that works too. So angle BEC. Sometimes it's hard to see with all these triangles in one, but it's just trying to get you to realize that there are different hash marks there that we got to look at. Okay, so this is where our thinking comes into play. I know that number 4 is an isosceles triangle. How do I know that?
There's 2 little lines on each corner.
On number 4? There's no lines.
Oh, number 4.
Yeah.
Things are equal on both sides, so
Yeah, so that's 21, right? That 21 is the same on each side, so that means that we're going to put hash marks there. Because I know that 21 and 21 is the same number, they're congruent to each other.
Wait, can I put like the little arcs on top? So
We are. So we need to find what these 2 angles are. How are we going to find that? Inside of a triangle is how many degrees?
180.
180, good. So I already know the top vertex angle is 38 degrees.
Subtract 180.
Okay, but let's just name these base angles X and X. And I'm naming them X because if I have two congruent sides, I have two congruent angles. So I know that these numbers will be the same. Chris's idea was to do 180 minus 38, and whatever we're left with, we could divide by 2, right? Because these numbers will be equal.
Yeah.
I think we should just keep practicing what we already learned, which was X plus 38. 38 will equal what? What's the interior amount of angles?
180.
Equals 180. I think that'll be the easiest one. All right, what's X plus X? 2X. And then plus 38 is equal to 180. Now what?
Minus 38.
So I'm left with 2X is equal to, what is 180 minus 38? 215? You're adding, subtracting. 180 minus 38.
Come on, Diana. Okay, sorry.
At least she's doing it. You don't even have a calculator on your desk. Look at a calculator. I got 142. You kind of doing it in your head, Brian?
Yeah.
Alright, so 2X equals 142. Alright, Diana, divide by 2. What do I get for X? 71, good. Alright, so that means that these two base angles there are 71 degrees each. If I were to add up 71 plus 38, I would get 180.
Yeah, I believe it.
Alright, let's look at number 5. In number 5, I already have the little hash marks here. Okay, so if I have the hash marks, I know that these base angles are also going to be equal. What does that square tell me? What is special about that square? It is equal to 90 degrees. Okay? So I can do X plus, what's this top angle up here going to be?
X.
It's also going to be X because my angles are the same. So I have X plus 90, which equals what? 180. What do you get? X plus X is 2X plus 90, which is equal to 180. I subtract 90. I'm left with 2X equals 90. Each of those angles will be what?
45.
Each of those angles will be 45. Alright, so we figured out that X is 45, which is basically 45 degrees. If X is 45 degrees, what is Y going to be? Think about your vocab.
25.
No, that's a linear pair. A linear pair are two angles that add up to what? 180. So do 180 minus 45 to give me Y.
135.
So Y
You're not adding
equals
as well?
135. What?
You're not adding as well, it's funny enough.
Can I add it?
Yeah.
Add what?
45 plus 90.
Yeah. Well,
Yeah.
yes. Yeah, you can do it that way too. Since they're like the exterior angle and the opposite interior angles. So there are different ways that you can solve most of these problems. All right, so the rest of our notes is just practice problems. So we're going to do practice problems up until lunch, and then you guys are going to do them, okay? The ones you do on your own, you can get credit for, by classwork group. All right, so I have this triangle here. I know it's isosceles because of the hash marks. So that means my base angles are going to be the same. What is x going to be? X is 72. Do you guys see that? I didn't even have to do any work there. All I had to know was that my base angles were going to be congruent.
That's the answer?
For x, yeah.
Mine is 102.
How'd you get 102?
I mean, 108.
How'd you get 108? Wait, I can get that. If you do, okay, so let's find y. We have y plus 72 equals 180. Remember, because it's two angles that are 72. All right, so now what is y going to be? You guys can work backwards and do 180 minus 72 equals y, same thing. You should get 36. Y equals 36 degrees. Any questions here? Look at number 7. Okay, so we have two triangles inside of one big one. I'm going to start with the bigger triangle. Is this an isosceles triangle?
No. Yes.
Yes, right? Have a hash mark there, have a hash mark there. That is isosceles. So my angles are going to be equal to each other. So you guys should have 3x plus 10 is equal to 5x minus 10. And I think for this class, if you guys want to use Desmos, you can go ahead and do that if you have your computer or if you have the app. Because you could type this right into Desmos and get what x equals. Or we can do it the long way. We can do it by hand. If I want to solve this, I'm going to subtract 3x. And I have 2x minus 10 is equal 10. And then I'm going to add 10. So I'm left with 20 equals 2x. Once I divide by 2, x equals what? 10. So we got what x equals. All right, type this into your calculator, Chris.
Huh?
What is 3x plus 10 plus, actually don't use your calculator. What's 3 times 10? Plus another 10.
41.
All right, so these base angles should be 40 degrees.
How'd you get that?
I just plugged it in. I got x plus 10. That's why I said if you guys have Desmos, you just want to plug this in, and I'll show you up here.
Every time you go to lunch.
No. Because even though Desmos makes the solving part easier for you, you still have to know how to use it. My computer's slow right now, but just wait a second.
What? She said her computer's slow. That's the name.
Right, if you go to your Desmos, and let's say for number 7, my equation was 5x minus 10 is equal to 3x plus 10. Zoom out so you see your answer. It tells me that my x value is 10 here. So instead of doing all that work that we just did, you could skip that and type it into Desmos. But you still have to know what to do with the information. You can't just do that and then do nothing else. Okay? So if these two base angles If these two base angles are 40, what is this top angle gonna be? What's your vertex angle?
Yeah.
Does that add up to 180? Huh?
Not even 100.
Guys, you're killing me. All you have to do is think a little bit further.
100.
There's how many degrees inside of a triangle? 180. If you have 40 and 40, how do you get the missing angle? Thank you.
Come on, now.
Guys, you started doing missing numbers, adding and subtracting in first grade. I know you guys know how to do this. You can figure out a missing number from 180. We got x. We plugged in x for 10, which is what our answer was. 3 times 10 is 30, plus 10 is 40.
Quick math. Quick math.
We're just plugging in numbers. There's no math there. You just type it into the calculator. All right, we're not even going to find y right now because I'm not confident that we can do that. All right, let's look at number 9. On number 9, let's look at this triangle. Is it isosceles?
Yes.
Yes, it is. I have those hash marks. So that means that my angles are going to be congruent, right? Let's say that this is angle Z. Let's just make up a, actually no. Go call it Z.
Extend to X.
It is X. Let's say this is X. How can I figure out what this X is right here? When I just wrote in. What's the relationship?
It's 180. Oh,
What's the relationship between those two angles?
linear pair.
There's a linear pair, which means there's two angles that add up to equal.
80.
Okay, so to find X, I can do 180 minus 115, and what do I get?
65.
All right. So if this X is 65 degrees, what is this X? 65 degrees. So how can I figure out what Y is?
Y plus 65 is 65.
Okay.
Alright.
Mhm.
Equals 180.
Okay. So let's do it all. 65 plus 65, subtract that from 180. As if you don't ever type this in yourself
I got
with your
50.
calculator, you're never going to do it on your own. Y is 50. So X equals 50 degrees, or sorry, X was 65, right?
Yeah.
The more we do this, the more you'll realize that our vocabulary is very, very, very important. If you're struggling with the vocab from unit 1 or 2, you may have to go back and look over those quizzes, because it still plays a part. All right, I want you guys to work on
Over easy.
work on 12, 14. Hold on, wait. Which one did we just do? 9. All right, the problems that you're doing by yourself, you are doing 11, 12, 14, 15. 11, 12, 14, 15.